the left-hand side next to the 6, and the 2x plus y is therefore going to go here. And the 4x plus 2y is going to go here. And then we stop and take a breath and say, does this really say the same thing that this does? Well, yeah, the first number here has to equal the first number here, and that's just your first equation. The second quantity here has to equal the second quantity here, and that's this. These wouldn't be equal if this wasn't equal to this, and this wasn't equal to this. Setting this equal to this, we get the first equation. This equal to this, we get the second equation. And now we hopefully understand pretty completely how this gets into this form. And now what do we have to do to get this into this form, into the matrix form, okay? The ultimate matrix form. And this is it. Well, the 6, -3 stayed the same, and it's kind of stayed the same all the way through. So I'm pretty sure we're going to be able to write the analogous thing here, which would be 612 instead of 6, -3. And then it's what? It's some matrix times xy. So we're going to have an xy here. And now we've just got to fill in the numbers in this matrix so that when this matrix is multiplied by the xy column, we get this. So there's going to be a first number here that multiplies x, and a second number here that multiplies y, and that has to give us 2x plus y. So what do those numbers have to be? Well, to get 2x, we've got to have 2 times x. We better have 2 here. And to get a y, which is a 1y, we better have a 1 times y. So it's 2, 1. And then to get this expression, we're going to have 4 times x. So first number in this row has to be 4 because that's what's multiplied by x. And the second number is going to get multiplied by y. And that number has to be 2. So there we've translated this equation into matrix form. Now, I didn't use real good foresight when I asked you to express all the matrices in the first problem, or all the equations in the first problem in terms of matrices, because there's an extra step. So if we look at the y equals 3x minus 4 and y equals 3x plus 2. If we look at this system, it doesn't look exactly like this one does, because in this system all the x's and y's were on the left and the numbers that were left over were left on the right. Well, that's all right. We can write an equivalent system. We can write the equivalent of each of these equations just by subtracting 3x here from both sides, and we get negative 3x plus y equals -4. And here, the x is on this side, we want the x's on this side. Well, if we subtract 3x from both sides, we end up with negative 3x plus y equals 2. Now, this is in a form similar to this, and it's amenable to putting into this form. So what do? Well, we say, okay, well, that means that negative 3x plus y, the column with this and this, has to equal the column with -4 and 2. Now we want to write that as what? We want to put it in this form where we have the column vector xy multiplied on the left by some matrix such that when we multiply it through we get this. Well, that means that the first row had better have a -3, so we get a -3x up here, and a 1 so that we get the 1y. And then the second row had better have, let's see, we got a -3x there, so we better have a -3 here to multiply the x, and y, so we better have a 1 here to to multiply the y. So there is the matrix form of this system. Yeah, I did that, and I did that rather quickly. Here it is. Okay, well, I did the same thing with the first system, but I'm going to do it a little more slowly. I'm going to rewrite it. Okay, so the first system is what? Y equals 2x plus 1. Y equals negative x plus 2. And we want to write this now, get it down to this form. So we want to get the x's and the y's on the left side and the numbers that are left over on the right-hand side. So we subtract 2x from both sides here. We get negative 2x plus y equals 1. We add x to both sides here. We get x plus y equals 2. Now I did the same thing up here. You see what I did? I didn't do the intermediate step, and I probably should have. As a matter of fact, I'm pretty sure I should have. Okay? We write negative 2x plus y, x plus y. That's just the two left-hand sides in a column, and we write the two right-hand sides in a column. Okay? If this column is equal to this column, then the first thing in the column here has to equal the first thing in this column. Well, that just says negative 2x plus y equals 1. That's what we have, and that's why we wrote it this way. Okay, and the second column, setting this equal to this, gives us x plus y equals 2. Then, we want to write this as a matrix multiplied by xy equals 1, 2. So what number needs to go here? What number needs to go here? This number is going to multiply x. This number is going to multiply y. It's the first row times the column, so it has to equal negative 2x plus y. How are we going to make that happen? Well, by putting a negative 2 here and putting a 1 here, so that negative 2 times x plus 1 times y matches up with what we have here. And then down here, we're going to put in a couple of 1s, because 1 times x gives us x and 1 times y gives us y. And now we've got a matrix equation. So we can translate a system into a matrix equation. Now it takes some practice before you get used to matrix multiplication and so forth. That's why we do homework. So I really hope everybody comes in next time having done the homework.